What up, LH2? Hopefully you're glad to hear my voice. Just sitting here recovering, watching my daughter's game via Live Barn. So it's a win-win situation. I get to stay home and get healthy and watch my daughter play. So anyway, let's get back to it. We're going to pick up where we left off, where Mr. Larson's been leaving off, solving quadratics. Again, we're looking for the x-intercepts. As Sam would tell us, that's where the y value would be 0, and we got to solve for x. So what we practiced 2 days ago, you were practiced by undoing. It was just x squared. So you're able to get the squared by itself, take the square root plus or minus. And then yesterday you were doing solving by factoring, where we would do the factors of the last number, add to the middle, do a little x thing, cheater method, whatever, and then you take each factor, set it equal to 0. Today we're going to kind of do a combination of both, and then this will lead us into the quadratic formula. Matter of fact, you can solve or you can complete the square as a proof for the quadratic formula. I geeked out and did that earlier today. So next week when I'm back, if you guys want to see it, I'll show you. You can look it up online too, but same premise. Right now, what I need you to do is the warm-up quick. So pause the video, try the warm-up. I am going to just start going through it here. But, yeah, if you want to give yourself time, go ahead and pause it. So what we're going to do, vertex of 2 and 3, and y is negative 29. Don't know a. X is negative 2 minus 2 squared. And then the vertex is plus 3. Negative 2 minus 2 is negative 4. Squared is 16. So this is 16a plus 3 equals negative 29. Subtract the 3 to both sides. You get negative 32 is equal to 16a. A is equal to negative 2. So then when we are going to write our equation in vertex form, we would do y is equal to negative 2 x, and then vertex was 2, 3, so x minus 2 squared plus 3. And then going from vertex to standard form, that's just my phone going off because I am an important and popular person when I'm not around. Those of you coming from Mr. Larson, he would say distribute the negative 2 to one of them. You could do it there. You could do it after. It doesn't matter. I'm going to FOIL this out first. X squared, and then that's going to be minus 4x plus 4. You can do the math. And then we got the negative 2 still out front. Distribute the negative 2 and add 3, so negative 2x squared plus 8x. Minus 8 plus 3 is minus 5. So that's going to be the final answer. What does it say? Minus 5. And that's going to be y equals all that stuff right up there. All right, our vertex is given to us. That was 2, 3. Axis of symmetry is the line x equals 2. It's going to split our graph in half. The y-intercept is 0, negative 5. And I know that because my c value is negative 5. Or if you plug in a 0, 0, 0, negative 5. Domain is all real numbers, or negative infinity to positive infinity. Our range, our graph is actually opening down, so our range is going to be y is less than or equal to, what's our vertex value, 3, or negative infinity to 3. It's increasing then, so if we go to 0, 1, 2, 4, I think this is 5 down there. I'm graphing this right now. 2, 3. Throw that other one out there. And our graph is going to look something like that. So it's increasing from negative infinity to 2 on the x-axis. And then at 2, it goes back down. So 2 to infinity. All right. So hopefully you're doing well. Check my math. Go ahead and, put in the comments section if I got something wrong. All right. Completing the square. There are your notes. I want you to write down this right-hand side of the notes. I kept it up there. We got 5 steps, and then we're going to solve by undoing, essentially, is what's going to happen. So, from standard form, we're going to move the C value to the other side of the equation. We're going to divide everything by the A term if it's something other than 1. Then we're going to take that B term, the new B term, divide it by 2. Take that number, square it, and then we're going to add it to both sides of the equation. All right, so all we're doing is we're manipulating an equation. One thing I want you to remember is if we add something to one side, you have to add it to the other side of the equation. All right, so that's the premise of what we're doing. If you do this correctly, you should be able to write it as something squared, something to the second power. And then we can go through and solve by undoing, essentially. Okay, so those are our steps. Move the C value, divide by the A, B divided by 2, square it, add it to both sides. All right, and then from there, you're going to have to figure it out and take your own notes. Ooh, this is a nail-biter of a game. It's 1-1 in third period right now. Craziness. All right, let's get rocking and rolling. All right, so first off, standard form. Got it. Good. Next thing we got to do is move the C value to the other side of the equation. So we got x squared plus 4x plus a blank, and I'm going to leave a blank there, plus a blank. Okay, so that's moving the C value. Divide by the A term. The A term is 1, so we don't have to worry about doing that. Step number 3 says take the B term, which is 4, divide it by 2, and get 2. And then we're going to square that bad boy to get 4. And then we are going to add 4 to both sides of the equation, right? So we're going to put it over here. If I add 4 to the left side, I got to put 4 on the right side, right? That is completing the square, right? Why do we call it completing the square? Well, now we're going to take this guy right here. Add on to those steps if you want to. We're going to take that guy right there, and we are going to factor it. So we're looking for factors of 4 that add to get 4. Well, that's going to be 2 and 2. Weird, it's the same number. So we are going to write it as x plus 2 times x plus 2, or x plus 2 squared. That's why we call it completing the square, because if you do it right, it's going to look exactly like this every single time. Something raised to the second power. And then when I add, maybe if that's green. What's going on? No. Yep, multiple windows not supported. That's why I don't want to do multiple windows. All right, add the 12 and the 4, and we get 16. Now we get to solve by undoing. All right, so we get to take the square root of both sides. And then remember, when we take the square root of both sides, we got to do that plus and the minus. We got 2 different answers, right? So we're going to get x plus 2 is equal to plus or minus the square root of 16, which is 4. So I like to write it as 2 different equations right now. Positive 4x plus 2 is equal to negative 4. And just split it apart into 2 separate answers. Subtract 2 to both sides. X is equal to 2. Or subtract 2 to both sides. And x is equal to negative 6. All right, here we go. Let's move that C value over. So we got x squared minus 6x plus something is equal to negative 36 plus something. All right, divide by the A value. A value is not there. Take the B term, divide by 2, you get negative 3. We're going to square it to get 9. And then we're going to make sure we add that to both sides of the equation. So we got x squared minus 6x plus 9 is equal to negative, it looks like negative 27? Negative 27, there we go. All right, again, the reason why we call this completing the square is this is going to be x, and then I want you to take a look at this guy right here. That b divided by 2 is negative 3. Well, I'm looking for factors of positive 9 that add up to get negative 6. Well, it's going to be negative 3 and negative 3. It's always going to work that way if we complete the square correctly. So this is going to be x minus 3 squared is equal to negative 27. Now we solve by undoing. Take the square root of both of the sides. Oh no, we have a square root of a negative number. Hopefully you've watched the videos and done your job. When we take square roots of negative numbers, we get the letter I. Oh no. So we have I times the square root of 27. Ooh, plus or minus, don't forget about that. And then we're going to break down 27. Okay, 27 is the square root of 9 times the square root of 3. Again, we're looking for perfect square factors here. That's why I chose 9 and 3. Well, that's the only other factor pair. So then square root of 9 is 9, radical 3. So this whole thing is going to look like x minus 3 is equal to plus or minus 3i times the square root of 3. And then if you want to write it as two different answers, you can. We want the negative radical 3. And when we add 3 to both sides, it'll be 3 plus 3i radical 3. Or x equals 3 minus 3i radical 3. And those are going to be our two solutions, all right? So I just want to go back to right here, talk about what we did quick. Okay, we completed the square. And then when we got to this spot right here, breaking down the square root of negative 27, that's where the I came from. And then we had to take and reduce that fraction down. Or not fraction, but radical down. All right, jump to number 3. Almost in standard form, except for I'm going to move that 8x over to the other side. So we had x squared minus 8x plus something is equal to 12 plus something. All right, what is that something going to be? Take the b term, divide it by 2. That's negative 4. We're going to square that bad boy, and that's going to get us 16. So we are going to add 16 to both sides of the equation. Call this completing the square, because now I can take this right here, factors of positive 16 that add up to get negative 8. That's going to be negative 4 and negative 4. So that's going to be x minus 4 squared is equal to 28. Okay, we get to take the square root of both sides now. We get x minus 4 is equal to plus or minus the square root of 28. Well, let's break down that square root of 28 quick. I'm going to break that down into the square root of 4 times the square root of 7. Square root of 4 is 2, so that's 2 radical 7. So this is going to be x minus 4 is equal to positive 2 radical 7. X minus 4 is equal to negative 2 radical 7. Add 4, add 4, add 4, add 4. And we get a grand total of x is equal to 4 plus 2 radical 7. And then x is equal to 4 minus 2 radical 7. So like I said earlier, it's a combination of both. Where you're factoring to get it into a square and then solve by undoing. This works all the time. It just is not pretty when, like in number 4, if numbers were not divisible by 2, then you get fractions and stuff like that. But it is what it is. All right. So we are going to move the C value. Divide by the A value. Since A is 2 this time instead of 1, we're going to divide everything by 2. And now we're going to take the B term. Divide by 2. And square it. And add that number to both sides. So then we're going to get x minus 2 squared. And I factor that left side is equal to -3. Oh no, we're going to have I again. Take the square root of both sides. And then we get x minus 2 is equal to plus or minus I times the square root of 3. Then we add to both sides. So this is another way to write answers. 2 plus or minus I radical 3. If you had to separate them, it would be x is equal to 2 plus I radical 3. And x is equal to 2 minus I radical 3. So I highly suggest if you did not do imaginary numbers with Mr. Larson last week, that would have been Monday. I highly suggest you get that done. Or after your test last week is when it was. I can't remember. All this stuff is blended together. All right. So that is the lesson. You can go ahead. We're not doing breakout rooms. But go ahead. Try these out if you'd like. We go from there. And then have yourself a wonderful day. The assignment is in the book. In Schoology there. Be ready to go for tests next Tuesday before we go on a break, just FYI. I know Mr. Sturm, if he hasn't shown that to you, I know I'm going to send out an email with the schedule and everything, and that's the way we're going to roll. So have a wonderful, wonderful evening, or actually it's day. It's evening for me right now, but have a wonderful day. Again, email me if you have any questions. Adios.